Hello class, we've got some notes here to refresh your memory about writing linear equations, and you want to be able to write linear equations given various types of information. So before we do that, we're going to go over the different forms. The first one is the slope-intercept form, which is y equals mx plus b, the much beloved form of students everywhere. Point-slope form is the one that I'm hoping to convince you to know and love, because you'll use that a lot more in your advanced math classes. Vertical lines are always of the form x equals some kind of constant, and horizontal lines are of the form y equals some kind of constant. So vertical lines, remember, are those guys. Horizontals are those. Other tidbits about vertical and horizontal: the slope is undefined for verticals. Slope is 0 for horizontals. Some people use these acronyms to help remember the components of the vertical and horizontal lines. Vertical, undefined x. Horizontal, 0, y. Alright, example 1. Choose 2 points on line L and write the point-slope equation for the line. So, basically when you're looking for 2 points, you want to find points that have nice grid intersections, the ones that you're not really guessing on. So these are looking pretty good to me. Alright, so there's line 1. I'm using the points negative 2, 2, and the points 1, 0. So the first thing that I need is the slope. 2 minus 0 over negative 2 minus 1. And the slope is negative 2/3. Which kind of makes sense, because you can see that this line is going down from left to right. The point-slope equation is super nice, because you can take either one of these points and use them in the x1, y1 position. So my equation is going to be y minus, and I'll just go ahead and use this one here, 2 equals negative 2/3 x plus 2, and you're done. Alright, so now if we want to convert this to slope-intercept form, because some people just are really kind of super attached to that, the first thing that we're going to do is distribute the negative 2/3, then add the 2 to both sides, and negative 4/3 plus 2 is 2/3. And that would be the slope-intercept form. Alright, letter C, find the slope of line 2. Line 2 is this one here, and that's our vertical line. So the slope is undefined. The equation of the line is going to be x equals whatever the x value that line is that goes through. So it's x equals 5. Line 3 is a horizontal line. The slope of all horizontal lines is 0. And the equation is going to be the y-coordinate that the line passes through, so negative 7. Oh, okay, sorry, I wasn't realizing that wasn't showing. So find the slope of L2. L2 is a vertical line. The slope is undefined. X equals 5. L3 is a horizontal line, so its slope is 0. Its equation is y equals negative 7. Next example, write an equation for the line containing these 2 points. And so let's calculate the slope first. Kind of always want to do that. And negative 5 minus 3. So we have negative 14 over negative 8. And we're going to go ahead and simplify that. So 7/4 is the slope. What point do I want to use? I'm going to go ahead and use the point-slope form. Making sure I'm not missing anything here. I think we look pretty good. So I'm going to go y minus 8 equals 7/4 x minus 3. It says, what form do you have to write the equation in? Well, you kind of don't have to write it in any form at all. You can choose point-slope. You can use the other point if you prefer. The y plus 6 equals 7/4 x plus 5. And if you want, you can convert that to slope-intercept form. And both of those would become the same slope-intercept form of a line. Alright, example 3. The equation for the line containing these 2 points is y equals 2. Without calculating the slope, how do you know this is the equation? Well, because you can kind of tell that they both have the same y value. And if they both have the same y value, then they must both be points on y equals 2. Okay, so we would say because, that's kind of funny, the y coordinate is the same. All right. Next section, parallel lines and perpendicular lines. You will recall parallel lines have the same slope. Perpendicular lines, the slopes are opposite reciprocals. For example, 2/3 and -3/2 are slopes that are opposite reciprocals. So example 4, what is the slope of the line that is parallel to y equals 1/4 x minus 2? Well, the slope would be the same. So in this case, the slope would be 1/4. What is the equation of the line parallel to that line that contains P23? Again, my favorite equation, point slope. Just throw it in. Y minus 3, 1/4, x minus 2. And it's not asking for a different form of a line, so let's just leave that one. What is the slope of the line perpendicular to this one? Well, we're going to take the opposite reciprocal of 3/4. What is the equation of the line perpendicular to the given line and passing through 3/4? Again, y minus 4, use the point slope form, -4/3 x minus 3. Look, we're like mowing this down. It's so nice. Graph the equations in part A in the coordinate plane, and what do you observe? Okay, so equation A, how do I graph this? Well, I'm going to do the first one in red. And remember, when you graph lines in slope-intercept form, you plot the y-intercept and then use the slope to find the other points. Up 1/4, up 1/1, 2, 3, 4. So this is y equals 1/4 x minus 2. And the other equation goes through 2, 3. But it also has a slope of 1/4. So here's what this one looks like. Oh, sorry, a little twisted. What do you notice? Well, they're parallel, which they should be, right? That's how we made it. So it's kind of nice confirmation. Let's try the same technique in letter D here. So we're going to graph 3/4 x minus 1/4. And your y-intercept is a little bit unfortunate, so I may be looking for another point there. So I'm going to go ahead and plug in the point 4. So then we have, I'm plugging 4 into the equation so that I don't have to use this y-intercept of 3/4. So that would be 3 minus 1/4 is 2 3/4. That's a little bit better. So we have over 4 up 2 3/4. And we're going to go down 4 over 3. 1, 2, 3, 4, 1, 2, 3. So here's our approximation of y equals 3/4 x. Oh, shoot, I did, I graphed the wrong one. I should have gone up 3/4. So I should have gone up 1, 2, 3 over 4. 1, 2, 3, 4. Did anybody catch that? Like, what is she doing? She's using the wrong slope. Where's the wrong one? This one. Okay, my bad. The other one, though, we're going to go through 3, 4. 1, 2, 3, 1, 2, 3, 4. And this one's going to have a slope of -4/3. Oh, would you look at that? Line that I made before. Okay, what do you observe? Well, they're perpendicular. So, which is how we made it to be anyway. Alright, last one. Find the value of k so that the graphs of these two equations are perpendicular. Well, that means we want opposite reciprocal slopes. So let's find the slope of each one. So this slope is easier to find because you can use the opposite of a over b trick. -6 over 24. Okay, so that slope is -1/4. So we want this slope to equal just a +4. So maybe move this equation around a little bit. I'm going to have -kx plus 7y equals -10. So the opposite of A would be positive K over B equals 4. Means I want K to equal 28. Alright, hopefully this video worked out for you, okay? If you have any questions, as always, do not hesitate to let me know. Thanks.